Okay, so on the worksheet, the first thing we want to look at, and we've talked about domain and range a little bit when we were looking at the ACT review information. So we have a relation and a function that we want to talk about. The second worksheet will get into some more of that information. But if we look at a set of numbers and we want to talk about the domain, do you remember what the domain is? Do you remember what we said it was? The x value. So domain means the same thing. Domain has one way we could talk about domain is we could say it's the x value. We could say it's an input. You could just call it x. Any of those mean domain. It's what can you put into a function so that if your function machine was your calculator, when you type it in, you don't get an error message. So that's what domain is. Do you remember what range is? The y value. So range, we could describe it as just the y value. You could call it an output value. If you put a number into a machine, it's going to perform a calculation and it's going to spit out an answer. We could call it as just y, or y means the same thing as f of x. So sometimes you could just see it as f of x. If you were to look at the table when we talk about x and y, we could say that f of x, that means the same thing as x and y. And you could talk about domain and range. That means the same thing. So you can look at any of those. Just keep in mind that domain is what you can put in for x. Range is what you get as an output or the answer. And then you can look at them as function tables. So if we look at this first page of the worksheet, relation, function, domain, and range. If you look at that first page, they give you a relation. So a relation, we're just going to talk about a set of ordered pairs or a set of points. We have ordered pairs here. You have 322, oops, and you have 90 and 34. If we were to look at that relation, it's as simple as this. What did we say domain was? X. Domain, think of this, if this helps. We talk about an XY coordinate point, right? Alphabetical order. Domain, range, alphabetical order. So if they want to know the domain, domain is 0, 3, and 90. That's it. So your domain, they list for you 0, 3, and 90, just the x values. If you want to talk about the range, we can look at the range, which means the y values, which are going to be 1, 22, and 34. That's the only thing. When you see that word domain, when you see the word range, don't sweat it. Something easy. X and Y values. So if you list the next one, in the next relation that they list for you, can you see you have the coordinate points 2, -5. I'm going to write them this way for a second. It has the points 4, 31. You have the point 11, -11. You have the point -21, 3. And if they ask you for the domain, there's your domain. Your domain values are 2, 4, 11, and -21, even though my line kind of crossed right there. Let me make that better. It's -21. And what are your range values? Yep. Your range values are just the y, -5, 31, -11, and 3. Now that's looking at it as a set of points. We will later get to it when we look at it as in terms of a graph. When you look at a graph, let me ask you this much. If I gave you, I'll go to another slide. If I were to give you a graph And it looks something like that. And if I ask you for the domain, what are you going to look for? Actually, I'm going to stop this. I'm not going to make this continue. I'm just going to stop it at an endpoint here. So I'm going to put an endpoint here, endpoint here. We're going to call this 4, -4, sorry. I'm going to call this over here 10. I'm going to call this 5, and I'm going to call this -3. If I ask you for the domain, what is the domain? -4 to 10. -4, does it include those values? Yeah, from my glance at it, it goes from -4 to 10. If I ask you for the range, what are you going to say about the range? You're going to say -3. Now I'm going to put a y down to 5. Why did I put the y there instead of an x? Because it's the y values. So looking at a graph, you can still figure out what domain and range are by just looking at where do your x values go from, where do your y values go from. Now there is a possibility, if I had those arrow tips on there, it would go on forever. And you would say from -infinity to infinity. Now this statement right here is written the same as this. It goes from -3 to 5. That means the same thing. It's not telling you it's a coordinate point. It's making reference to a set of values. The top one would be from -4 to 10. Inclusively, because I have the brackets. Okay with that? Or is there a question? Because I'm going to add one more thing to that. Now I'm going to switch it up, and this was where a video is going to be important. Or maybe I better just draw new graphs so that I don't throw that off for anybody. Let's do this. Put it in this way. Okay, given this graph, what if I ask you for the domain? What is the domain? -infinity to 2. Now, if I were to write that, I would say it's -infinity to 2. You can't include -infinity. That doesn't have an ending spot. So we just have to leave it as -infinity. So I don't put the equal sign there. Does it include 2? No. That's what the open circle is. If I had that as a closed circle, it would include 2. So in this case, your answer is going, if I wanted to write it using the brackets like I did last time, we don't have the brackets because brackets means when it's equal to. So in this case, I could show the domain as -infinity to 2. No brackets this time. What about the range? What is your range? -infinity to 1, 2, 3, 4. So I go from -infinity to 4. Does it include 4? Yeah, it includes 4. I tried to get it so it looks like it touches right there. If it includes 4, then it's less than or equal to 4. Now, how do I show that? In what is known as interval notation, which is this notation with parentheses and brackets. Well, can I say it's equal to -infinity? No. And if it's not equal to, you use a parenthesis. I go from -infinity. Does it equal 4? Yes, so you put 4 with a bracket. You see the difference between parentheses and brackets. This is known as interval notation. Here you're talking about just stating it as a set of values. Sometimes they'll say X is an element of the real such that. Another way you could see maybe the domain written is they would put it in words so they can show it in set notation, saying X is an element of the reals such that X is between negative infinity and 2. All of these notations right here all mean the same thing. And all they're doing is telling you what the X values are. And they stick a word with it called domain. Yes. What did you say? The red one hurts your head. I will try to avoid that. Oh, the notation. If you talk about Saxon, and if you were in your textbook right now, they use this notation. My students would walk away knowing this, and then all of a sudden they're coming back and they're like, I don't know. I go out to college and they're showing me something like this. This is the way that it's shown a lot in college. I'll just tell you that much right now. Some students like this, but set notation would be really here. And you could just talk about it graphically. It's like this. All of those mean the same thing though. Okay, so let's look at part 1, if you turn the page. I'm going to give you a few seconds to answer 1, 2, and 3, and you can do it with a partner if you want. Oh, a few seconds. Okay, I got to give you a minute. I'll see where you're at after a minute. Number 1. What's the domain? -1, 2, 1, 8, and 9, right? What's the range? Not so bad, right? Now that you know what they actually mean. 2. Domain? Did you get those? 5 points. 1, 2, 3, 4, 5. 5 points. Range? All those 5s. The next one, we panicked a little bit. Not really, but it's like, what do we know? When we look at number 3, if we talk about the domain, it's going to be the first value in each set of parentheses, right? So we're going to have the little ribbon symbol, right? The next one is an airplane, so we could draw the little airplane here. Yeah, I think so. What's the next one?
Like a metal?
A locket or something, or what? I don't know. Something that looks like, I don't know, something like that. I don't know. What's the next one?
Question mark.
Question mark. And the next one? Oh, bicycle. I don't know if I can do the, oh, I don't know. Okay, bicycle. I don't know. That's a pretty bad bicycle. Oh, wait, bicycle space. Oh, same bicycle though, right? What's the next one? I don't know. Looks something like a, oh, we got something like that where this is all dark right here, and then you get this thing up here. Then it kind of, I don't know, something like that.
Yeah.
What's the next one? A beach. We got an island right here with a palm tree on it. Okay. There's your domain. What is your range equal to? No. Chili pepper. A windmill. Oh, like one of those hats with the things on it. Little propeller hat. Oh, now we got another bicycle, don't we? I don't know. Some here, I don't know. I can't draw my bicycles, but anyway, so you get your bicycle here. The next thing, you got a shield, right? Oops, that wasn't. Okay, something like that. Shield. Next one is a, I'd say the back end of a bus here. Okay, we got the back end of the bus there. And the next one. It looks like a little hangman type deal to me. Something like that. And then your last one is a road. We got a highway going right here. Okay, whatever. Okay, that's all they want. Okay, so you get the point of what a domain and range is, correct?
Yes.
Sweet. The next thing then. Part 2 says which relations below are functions. Okay, so hold that thought, and I'm going to tell you the difference between a relation and a function. Okay, a relation is you have pairs of numbers, ordered sets of numbers. You've already looked at relations. To make that a function, all right, here's the problem. To make it a function, we got this problem. If you type a number in your calculator, oh, here, for an example, if I tell you to take the square root of 9, what's the answer to that? Or -3. Because it says what number times itself is equal to 9. So 3 times 3 is 9, and -3 times -3 is 9. But when you type it in on your calculator, what's your calculator going to give you for an answer? 3, because it's been programmed to give you the positive values. But really, you could have a -3 as an answer. Just unfortunately, it's been programmed that if you're going to want the negative answer, you have to put the negative sign in front of the square root of 9 so that you get an answer of -3. And really, the answer of this would be -3 or 3. And then you put the minus sign right there. How does your calculator know what value to give you? Well, it's been programmed. But if it doesn't, it's going to give you an error. What we want when we talk about a function is we're going to look at it in this format. We have 2 separate circles here. Okay, those aren't circles. You have 2 separate lists of numbers. One of them is the domain, which is what values? X. So I have a domain here, and I have a range over here. So if I just put some numbers in here, I don't know, I'm just randomly picking some numbers, and I'm going to put numbers over here, 5, 2, 9. What has to happen is when I put a number into the calculator to perform a function, it better come out with a number. I put this in here, it better come out with an answer, and if I put 3 in, it better come out with an answer. That gives you a function. When it becomes something that is not a function, is better described with another example, which is when I were to come up with my 2 sets of numbers here. You have your domain and range, and this is what can't happen. If I put 2 into my function, I get an output. Let me do this. Let me add another one here. If I put 3 into my function machine, it's going to produce an output. But if I put 4 into the machine, it goes with 9 or it goes with 2. Now, if that's the case, you get this 4 and the 2, your calculator is going to be pretty confused on which one it gives you an answer of. So if it's a Texas Instrument, does it give you the answer of 9? And if it's a Casio, it gives you the answer of 2? If it came from Walmart, does it give you an answer of 9? And if it came from Target, it's 2? I don't know. If I look at this, because if we look at the example in on your paper, does it give you these bubbles or anything? No. But what it does give me, if I were to look at this, I could talk about this as coordinate points. If I put 2 in, here's a coordinate point. If I put 2 in, what's the y value? 2 goes to 2. There's a point. If I were to talk about another point, what's another point that I have here? 3, 5. I could talk about the point 3, 5. If I put 3 into the equation, I get 5 as an output. What's another point that exists? 4, 2. What's another point that exists? 4, 9. So if I had a list of points, if I talk about the list of points up here, the list of points I have here are what? 2, 2, 9. What's another point I have? 3, 2. And another point I have is 4, 5. There's my points there. So if it is not a function, so this right here is not a function. If it is not a function, that means that you have an x value that has 2 different y values. If it is a function, every x will be paired up with a y value. Now, does that mean what happens if I take my 2 values here, and if I stick a 7 over here, and I say 7 gets mapped to 2? So I have another point over here, 7, 2. Is that still a function? Yes, it is, because when I put 7 in my calculator, do I get an answer? Yes, that answer is 2. When I put 7 in, it tells me 2. It's okay if I put 3 in and get an answer of 2 as well. It just gives me an answer. And it only has one answer to pick from. 2. Unlike here, it's got 2 answers to pick from. So in summary, if you're looking at a list of points, when they talk about domain, you need to make sure you don't have a duplicate x value. If you do, these y values have to be the same. If they're not the same, then it's not a function. What does that mean graphically? If we talk about it graphically, a function, you can do something called a vertical line test. If you have a graph, you can use a vertical line test to come up with your function. So, I don't know. Somebody want to come up here and draw something for me? Okay. Jane, you want to? There. Okay, so Jaden drew this for me. If I want to see if that is a function, what you have to do is something called the vertical line test. Remember, for each x value I have, can I have 2 y values?
No.
No, you can't. So if I look at this, I'm going to do the vertical line test. Here's the vertical line test to determine if this is a function. You're going to take a vertical line and you're going to move it across. And does it touch your function in one spot all the way throughout? Well, right in this range right there, that gets a little questionable. Was that meant to go straight up? No, it wasn't. Okay, so can we do this? How about that? Okay, is this a function? Would you say this is a function or not? Yeah, that is a function because as you go across, it crosses only in one spot. So I don't have duplicate values. Let me graph another one for you, and I'll do this one. No offense, Jaden, you did perfectly fine. Great example. If I just give you a normal parabola, is that a function? Yeah, it is. No matter what x value you pick, as oops, that didn't work right. Whoops. Oh my goodness gracious. Oh, now I'm not even on the line tool. Okay, right there. Hopefully that's vertical. It looks like it leans. Something leans to me up here. No, it's straight. Sweet. All right. So as this moves across, is it going to cross your graph only in one spot all the way through? Touching one spot, one spot, one spot, one spot, one spot, one spot, one spot. Yeah, that's a function. But remember, if we graph something that looks like this, x equals y squared, instead of y equals x squared, the graph of that looks something like this. Is that a function? No, because if I do this vertical line test, it's not vertical. All right, so if I do this vertical line test and I move this across to right there, what do you notice? Yeah, if this is x is 3 right here, what do I know? It's got a point up here, and it's got a point right there. Your calculator's going to be confused. I don't know. Do I tell them the answer is 5, or do I tell them the answer is -2? It's going to give you an error. Do you see the difference? Whether it's graphically or whether you are looking at it as a set of points. That's the difference between a relation and a function. Okay, so on your sheet, I will give you a couple of, I'll give you 2 minutes. Can you answer 1 through 3 on part 2? Which ones are functions? Is 1 a function?
Yes. Yes.
Is 2 a function? Is 3 a function? Why is 2 not a function? You have 2 of these that are 13, but if I look at the output, the outputs are different. So because of that coordinate point 13, 14 and the coordinate point 13, 15, if you were to graph those 2 points, you would go over here to 13 and up here to 14, and then you go 13 and 5. What do you notice about the vertical line test there? It crosses in 2 spots. So it doesn't work. Your calculator's confused. You understand the difference? Okay, answer 2 and 3 for me. Number 2. Oh. Number 2. Which relations are functions for number 2? Is number 1? Yes. 1, 2, 3, and 4. This is yes. It is a function. Is 2?
No.
No. Why? You have 3, 4 as a point, and you have 3, 9 as a point. Is 3 a function?
Yes, it is.
Yes. Is 4 a function?
No, it is not.
No. Why?
Yeah, 2, 8.
You have the coordinate point 8, 11, and you have the coordinate point 8, 19. And because of that, that is not a function. If we look at number 3, is number 1 a function?
No.
No. Why not?
3, 4, and 3.
You have the coordinate point 3, 4, and you have the coordinate point 3, -9. Is 2 a function?
Yeah.
Yes. Is 3 a, oops. 3 is no. Why? You have 0, 4, and you have the coordinate point 0, 0. Is 4 a function?
No.
No. You have the coordinate point 6, 17, and the coordinate point 6, 19. So it is not a function. Number 4. Number 4 says, for the following relation to be a function, x cannot be what value? So you have the coordinate point 8, 11. You have the coordinate point 34, 5. You have the coordinate point 6, 17. And you have the coordinate point x, 22. X cannot be what values? X cannot equal 8, 34, or 6. If it does, you would have 622, 617. Can't have that. If it were 34, you would have 34, 5, 34, 22. If it were 8, you would have 8, 11, 8, 22. Cannot be any one of those 3 integers. Number 5. Number 5, what can't x be? X cannot equal 12, 13, or -2?
Wait a minute, what? Well, -11, 13.
I did. Sorry, I just answered number 6 because I didn't look at the values up above, because when I turned the page, I did not see that. Sorry. It says you have the coordinate points. I'm just going to write them now so I don't do that. 12, 13, -11, 22, and then you have the coordinate point 33 and 101, and then you have the coordinate point x 22. Sorry. What can't x be? 12, -11, or 33. Now, it cannot. Oh, yes, it can be. Very good. Way to go, because it's 22 in both, right? So those are the only two. Wow. I overlooked the problem, looked at the wrong lesson set, and then overlooked -11. Good job, Grace. -11 does work because it's still going to give you that same point. So if you were graphing it, you would go -11, 22. And I just answered that question for you not too long ago. I said, when you plot it, it's going to be the same point. Okay, what about number 6? I got to stop this because I can go real quick maybe. 6, what can't x be? It cannot be 13. Oh, now I'm on the wrong one. I'm still on the wrong one. So for number 6, x cannot be 12, 13, or -2. So for number 7, x cannot equal 13, 12, or 16. So your assignment is that next question in that box dealing with Alex and Lillian.